Good day, dear students, friends, and parents who are assisting their children in accomplishing their modules. This tutorial video lesson is about factoring polynomials for quarter 1 and week 1 of the most essential learning competencies in Mathematics 8. Are you ready? Let's go! Okay, so before we proceed to factoring polynomials, let's have first the meaning of factoring. What is the meaning of factoring polynomials? So, factoring polynomials is the inverse process of multiplying polynomials. Say 2x times 3x equals 6x squared. So 6x squared equals 2x times 3x. But how do we factor polynomials? So the first step in factoring a polynomial is to find the GCF of all its terms. Then we write the polynomial as a product by factoring out the greatest common factor or GCF from all the terms. The remaining factors in each term will form a polynomial. Greatest common factor is the largest quantity that is a factor of all the integers or polynomials involved. In finding the GCF of a list of integers or terms, there are certain steps to be followed. Number 1, write each number or polynomial as a product of prime factors. Number 2, identify common prime factors. Number 3, take the product of all common prime factors. And then if there are no common prime factors, the GCF is 1. For example, find the GCF of each list of numbers. Number 1, 12 and 8. So the factors of 12 are 2 times 2 times 3, and factors of 8 are 2 times 2 times 2. So the GCF or greatest common factor is 2 times 2 equals 4. For number 2, 7 and 20, factors of 7 are 1 times 7, while 20 are 2 times 2 times 5. So there are no common prime factors, so the GCF is 1. For number 3, we have the numbers 6, 8, and 46. Factors of 6 are 2 times 3, and factors of 8 are 2 times 2 times 2. And then for 46, the factors are 2 times 23. So the GCF is 2. Find the GCF of each list of terms. Number 1, x cubed and x to the 7th. For the factors of x cubed, we have x times x times x, while the factors of x raised to 7 are x times x times x times x times x times x. So the GCF is x times x times x, or x cubed. For number 2, we have 6x to the 5th and 4x cubed. So the factors of 6x to the 5th are 2 times 3 times x times x. And then for x cubed, the factors are 2 times 2 times x times x times x. So the GCF is 2 times x times x times x equals 2x cubed. For number 3, we have a cubed b squared, a squared b to the 5th, and a fourth b to the 7th. For the factors of a cubed b squared, we have a times a times a times b times b. While for a squared b to the 5th, we have a times b times b times b times b. While for a4 or a raised to 4 b raised to 7 equals a times a times a times a times b times b times b times b times b times b times b. So the GCF is a times a times b times b, or a square b square. Always remember that the GCF of a list of terms contains the smallest exponent on each common variable. The GCF of x cubed y to the 5th, x to the 6th, y to the 4th, and x to the 4th, y to the 6th is x cubed y to the 4th. X cubed is the smallest exponent on x, while y to the 4th is the smallest exponent on y. Is there a pattern to be followed to easily factor polynomials? Now let's proceed to the factorization patterns. Letter A. Determine if there is a common monomial factor. Find the GCF and divide each term of the polynomial to get the second factor. For example, we have 3x minus 12 equals 3 times the quantity x minus 4. 3x is divided by the GCF 3, the result is x. 3 is the GCF of 3 and negative 12, while negative 4 came from dividing negative 12 by 3. Example number 2, we have x squared y squared minus 3xy squared equals xy squared times the quantity x minus 3, where x is the smallest exponent on x, while y squared is the smallest exponent on y, and xy squared is the GCF of x squared y squared minus 3xy squared, and x squared y squared divided by the GCF xy squared is equal to x, while dividing negative 3xy squared by the GCF xy squared will give us negative 3. For example number 3, we have 6 times x minus y plus a times x minus y equals 6 plus a times x minus y. Take note that x minus y is a common factor to both terms. Example number 4, we have b minus a. So first thing to do is to factor out negative 1 from the given binomial. And then b divided by negative 1, the result is negative b. Then negative a divided by negative 1, the result is positive a. And next is simplify. So our answer is the negative of the quantity a minus b. Letter B. If the polynomial to be factored is a binomial, take note of the following patterns. First, the difference of two squares. We have a squared minus b squared equals a plus b times a minus b. Take note that a is the square root of the first term a squared, while b is the square root of the second term b squared. In the binomial factors, be reminded that the signs will always be opposite signs. So just like the positive and the negative that you can see there. For example, we have 9x squared minus 25y squared equals quantity 3x plus 5y times the quantity 3x minus 5y. So what to do? You get the square root of the first term, 9x squared, that is 3x. And then get the square root of the second term, 25y squared, that is 5y. And then write the factors in the binomial form, just like what you can see on the screen, 3x plus 5y times 3x minus 5y. So do not forget that the signs of the binomial factors will always be opposite signs, positive and negative. For the sum of two cubes, like a cube plus b cube, for the binomial factor, you have to get the cube root of the first term a cube, that is a, and then get the cube root of the second term b cube, that is b. So we now have the binomial factor a plus b. And then for the trinomial factor, we get the square of the first term a in the binomial factor a plus b. So the square of a is a square. And then for the middle term of the binomial factor, simply get the negative of the product of the first and second term of the binomial factor a plus b. So product of the first and second term is a times b, that is ab. So the negative of ab is negative ab. And then for the last term of the trinomial factor, you simply get the square of the second term b in the binomial factor a plus b. So the square of b is simply b squared. Next example, we have 8x cubed plus 27y cubed. So the same step, we have to get the cube root of the first term 8x cubed, that is 2x, and then get the cube root of the second term 27y cubed, and that is 3y. Take note of the sign of the binomial factor, that is positive, because of the sign of the given sum of cubes, or the given cubes, which is addition or positive. Now let us proceed to the trinomial factor. The first term of the trinomial factor is simply the square of the first term 2x in the binomial factor 2x plus 3y. So that is 4x squared. And then the second term of the trinomial factor is the negative of the product of the first and second term of the binomial factor 2x plus 3y. So if we multiply 2x and 3y, the result is 6xy, and the negative of 6xy is simply negative 6xy. Then the last term of the trinomial factor is simply the square of the second term 3y in the binomial factor 2x plus 3y. So if we are going to square 3y, the result is 9y squared. Next, the difference of two cubes. For the difference of two cubes, put in mind that for the binomial factor, the sign in the middle of the two terms will always be negative. Okay, let us proceed. First, we get the cube root of the first term a cubed, that is a. Then, for the second term of the binomial factor, we get the cube root of the second term b cubed, that is b. Then for the trinomial factor, get the square of the first term, a, in the binomial factor a plus b, so that is a square. And then for the middle term, we get the negative of the product of the first and second term of the binomial factor a minus b. So the product of a times negative b is negative ab. Then the negative of negative ab is simply positive ab. Next, we get the square of the second term b in the binomial factor a minus b for the last term of the trinomial factor, and that is b square. Another example, we have x cubed minus 64. So the same step, we have to get the cube root of the first term x cubed, and that is x, and then minus, since we are on the difference of two cubes, so the binomial factor will always be separated by a minus sign. Next, get the cube root of the second term, negative 64, that is negative 4. Then square the first term x in the binomial factor x minus 4, so the square of x is x squared. Then second term of the trinomial factor is simply the negative of the product of the first and second term of the binomial factor x minus 4, so that is positive 4x. And then get the square of the second term, negative 4, in the binomial factor x minus 4, that is positive 16. For letter C, factoring a perfect square trinomial. Suppose we have x squared plus 2xy plus y squared. The factors are x plus y and x plus y, or simply quantity of x plus y raised to 2. How to get the factors? First, we have to get the square root of the first term x squared, that is x, and then get the square root of the last term y squared, that is y, and then we write the factors as x plus y and x plus y repeatedly. So put in mind that the sign between the two binomials is always positive, since the sign of our middle term 2xy is positive. In this pattern, take note that our middle term 2xy is simply twice the product of the first square root, or twice the product of the square root of the first and last terms. Just like in x times y, that is xy, twice xy is simply 2xy. So always remember that pattern. For example 1, we have middle term is positive, just like what was shown you earlier. The first and last terms are perfect squares. So we have x squared plus 6x plus 9. X squared is a perfect square, and 9 is also a perfect square. Take note that 6x is twice the product of the square root of the first and last terms, which are x and 3. X is simply the square root of the first term x squared, while 3 is the square root of the last term 9. So if we are to multiply the first and the second term, we we have x times 3 or 3x, and then twice 3x, it will give us the second term, positive 6x. So express the factors as x plus 3 and x plus 3, or simply the quantity of x plus 3 raised to 2. Example number 2, we have the middle term is negative. So in the given, we have 4x squared minus 20xy plus 25y squared. This is very different from the previous examples because our middle term here is negative. So in our answer, in the factors, in the binomial factors, the sign separating the binomial terms or the two terms should always be negative. Now, how to get the factors? We simply get the square root of the first term, 4x squared, that is 2x, and then get the square root of the last term, 25y squared, and that is 5y, and then write the factors as 2x minus 5y and 2x minus 5y, then simplify, which give us 2x minus 5y square, or the quantity of 2x minus 5y raised to 2. Letter C, factoring general trinomials. Suppose we have p squared plus 5p plus 6. Step 1, we are going to list all possible factors of 6. Just like what you can see in the table, we have 2 times 3, we have 6 times 1, negative 2 times negative 3, and negative 6 times negative 1. For step 2, we are going to find the factors of 6 whose sum is 5. So in the table, we have 2 plus 3 equals 5, 6 plus 1 equals 7, negative 2 plus negative 3 equals negative 5, and negative 6 plus negative 1 equals negative 7. So what we are looking for is a sum of two factors that will give us the middle term, or that will give us the numerical coefficient of the middle term 5p, which is 5. So the factors that we are looking for are 2 and 3. Therefore, the factor of p squared plus 5p plus 6 equals the quantity of p plus 2 times the quantity of p plus 3. For example 1, we have m squared plus 4m plus minus 21. Step 1, list all possible factors of negative 21. Just like in the table, we have negative 3 times 7, we have negative 7 times 3, negative 21 times 1, and negative 1 times 21. Step 2, find the factors of negative 21 whose sum is 4, our numerical coefficient of the middle term. So, just like what is presented in the table, we have sum of factors of negative 21. Negative 3 plus 7 equals 4, negative 7 plus 3 equals negative 4, negative 21 plus 1 equals negative 20, and negative 1 plus 20 equals 19. So the only factors that will give us a sum of 4 are negative 3 and 7. Therefore, the factor of m squared plus 4m minus 21 equals the quantity m minus 3 times m plus 7. For example 2, we have 2y cubed minus 6y squared minus 36y. Step 1, factor out the greatest common monomial factor 2y. So 2y cubed minus 6y squared minus 36y equals 2y times the quantity y squared minus 3y minus 18. So we arrive at the trinomial factor by dividing each of the term in the given trinomial by the GCF 2y. Just like in 2y cubed divided by 2y, the result is y square. Negative 6y squared divided by 2y, the result is negative 3y. Negative 36y divided by 2y, the result is negative 18. Step 2. List down the factors of negative 18. So in the table, we have negative 1 times 18, negative 2, 9, negative 3, 6, negative 6, positive 3, negative 9, positive 2, and negative 18, positive 1. Then after listing the factors, we proceed to step 3. So we'll be finding the factors of negative 18 can give us the sum of negative 3, our numerical coefficient of the middle term. So here are the sum of the factors of negative 21. We have negative 1 plus 18 equals 17, negative 2 plus 9 equals 7, negative 3 plus 6 equals positive 3, negative 6 plus 3 equals negative 3, negative 9 plus 2 equals negative 7, and negative 18 plus 1 equals negative 17. So, the factor of 2y cubed minus 6y squared minus 36y equals 2y times the quantity y minus 6 times the quantity y plus 3. Okay, that is all for today. Thank you for watching, and I hope that you have learned something from this video. See you again in my next tutorial. Thank you. Bye-bye.